Hello,
Yeah.
I welcome all the participants to this webinar from ICID Central Office, New Delhi. And I request our Secretary General, Mr. A.V. Pandya, to give the brief introduction of the seminar, and then the speaker, Dr. J.P. Cho.
So, welcome all the participants and the faculty to this webinar on seamless climate service and downscaling for climate change adaptation. It's a very important topic because climate change has become important all across the world. We all have to find methods of resilience to it. And one of the key issues that remain is the prediction and the situations that we are likely to encounter at short notices, which we have to adapt to. And for that, the climate change adaptation has a crucial issue of downscaling of the models. We have got the large number of global circulation models, and also we have got large scale long-term forecasts which have to be downscaled at the minor and field level, where it is possible for the farmer or the individual water user to respond to those situations. So from that side, I think this particular seminar is going to be very useful to all of us. And the webinar will be given by Dr. J.P. Cho from USA. Currently, he is working in the APEC Climate Change Center as a team leader of the climate application team. APEC Climate Change Center is a governmental institution, and it conducts research in the area of climate prediction, analysis, and climate change application. Dr. Cho has received his doctorate degree from Virginia Tech in 2007. Dr. Cho also worked with US Department of Agriculture and Agricultural Research Services from the year 2007 to 2011 as a research associate. So now we welcome Dr. Cho for the webinar. Thank you.
Yeah, thank you for introducing. And actually, my talk is the seamless climate service and downscaling for climate change adaptation. And actually, I've already actually introduced, so I want to skip this slide. And this talk is an overview. It contains climate change concept of the SDG and climate changes, and next is seamless climate information. What is the seamless climate information and downscaling? And then actually user-centered downscaling platform, actually which is developed by APCC. I want to introduce it. And use of seamless climate information, actually case study in Korea, in Thailand, and I want to finally introduce APCC's climate service and goals. So first, maybe you're familiar with the climate changes and global warming. And the global warming is the increase of temperature, average temperature of the Earth, and that caused that the different kind of the impact, climate change impact in regional, in local, and something like that. It includes some changes in wind pattern, humidity, and rainfall, and etc., something like that. So, but we are not interested in this kind of a global average increase of the temperature increase, but we are interested in what is the impact of that climate changes in my country or in my region or in my some study area, something like that. This picture actually shows that one agricultural reservoir in Korea during the drought season, and that's we are interested in. What is the impact in my actual area? So before that, we need to understand what is the climate change and what is the climate variability. Climate change is the very long-term trend, decrease or increase trend of the climate condition, climate characteristics. But that's the very important information for actually prepare something for the future. But we also need to focus on this climate variability. Actually, this is a short-term year-to-decadal rise and fall about the trend. So we have to actually take care of this kind of a long-term trend and actually short-term variability within that adaptation against the climate change. And there is two different approaches for responding to that. Hello? Yeah.
Yeah, it's okay. Please continue.
Yeah. The first one is the mitigation. Mitigation is the effort to reduce the greenhouse gas which causes global warming. But the problem is we are experiencing the negative climate impact, such as climate-related disaster, including flooding and drought, etc. So we have to think about another approach we call adaptation. So adaptation is the action to actually cope with the negative effect of climate changes. But as you know, the Paris Agreement actually emphasized on the adaptation. Previously, there was a Millennium Development Goal, MDG, talks about the mitigation. But recently, after Paris Agreement, actually we are focusing on both mitigation and adaptation altogether. Because even though we succeed to reduce the greenhouse gas through the international cooperation, but the effect of that reduction in the greenhouse gas usually takes a long time. But during the time we experience the negative impact in our local, actual regional area. So that's the reason we need to focus on adaptation. So the SDG, which is a 2030 agenda for sustainable development within the UN umbrella, actually it talks about 17 goals. And as you can see here, the climate change action has been included within that SDG first. But as you can imagine that climate change action has the direct or indirect influence, the linkage between other goals, such as the food and water and energy, something like that. So let's think about climate action. What the climate action talk about? And as you can see here, the climate action talks about strengthening the resilience and adaptive capacity to climate-related hazard and natural disaster. So it means we have to prepare some climate change measure in order to prevent that negative impact. But the other important thing is, even though we know that the efficient climate change measures, we have to include that measure within national policy and strategy and planning, because without that national actual approach, actually the science-based information is useless. But the last thing is the action of the people. Even though we have the scientific knowledge and we know we have some national policy, but if the people actually does not move, actually there is nothing will not be changed in the world. So we have to actually consider some capacity building of the people, human and institutional capacity on climate change mitigation and adaptation, both of them. But how about the goal 6? It talks about clean water and sanitation. The overall, the very important thing is maybe we need to provide some affordable drinking water with a good water quality, and that's a very important thing. But in order to do that, we also we need to consider the absence of the water use. In ICID, we are talking about irrigation, but we can actually construct new dams for actually getting more water for water supply for agriculture sector. But even though we have the same the infrastructure, if we can increase the efficiency of the water use, maybe we can be adaptive to the negative some climate change impact, something like the drought. Also, we have to, in order to do that, we need to consider some integrate approach. Sometimes integrate water resource management is one of the required approaches, and so we also need to think about ecosystem, and it talks about this kind of things. But to be adaptive to that climate changes, maybe the climate information is a starting point we need to consider. So you are already familiar with the weather forecasting. It covers maybe 1 week. And also you are very familiar with the climate change scenario. It tells about very long future, such as 30 years later, 50 years later, 100 years later. But you are not familiar with this kind of forecasting information between this weather and climate changes. Between these two information, maybe the 1 week to 1 month, covering 1 week to 1 month, we call sub-seasonal to seasonal. S2S is available, and 1 month to 1 year forecasting we usually call seasonal forecasting. As you can see in this figure, this kind of forecasting information it can be used for disaster risk management, and this kind of climate change scenario is appropriate for climate change adaptation. So as I mentioned in the beginning, we need to think about climate change is a long-term trend, and also we need to think about the climate variability. So this forecasting information is useful that climate variability, and this climate change scenario is appropriate for the long-term adaptation. So if we agree that we need to consider the sameness, different kind of climate information is a left side, maybe we need to do something in order to use in the water sector. When I joined the APCC 6 years ago, as a model developer, actually, if I have any climate projection information, I can do something in my the water resource management sector. But my impression was at the time, actually, there was a big gaps between climate sector and application sector, and I want to show that in later. But so that's the reason we need to do. We need to consider some downscaling of the climate information. So we are, as an expert, we are preparing some adaptation and mitigation measure, and there is two different approaches. One is the non-structural approaches, and the other one is structural approaches. If that climate projection and climate forecast information is accurate, maybe we can select some structural approaches. But the problem is the climate information contains lots of uncertainty. So that's a reason we need to consider some non-structure and management approaches in the adaptation for the climate changes. So we usually call it no regret approaches. So this is the framework which I drew when I joined the APCC 6 years ago. As I mentioned, there's a climate change scenario data, and I need to do some statistical downscaling for use in my water sector. And also, APCC provides seasonal forecast information for the user, but requires different kind of statistical downscaling. After that, as an expert, we can do lots of analysis, including some hydrology, water quality, and groundwater, etc. And after that analysis, maybe we can provide the information to the users, including public and some manager or researchers and policymakers. Why there is lots of uncertainty within that climate information? Because this left side is a real Earth system, and climate scientists, actually, they are, as an expert, they develop some global climate model. They just mimic the process within the Earth system within the simulation model, but the problem is the resolution of the model is very low. Actually, on right side, you can see the output. One resolution usually it cover 100 kilometers to 300 kilometers, something like that. But as I mentioned, we are interested in my country, my region, and my city, something like that. So there is another approach. There is approach for that kind of for creating that kind of some fine resolution data. They develop the regional crime model, RCM. So this is one of the approaches for downscaling, but it requires lots of computing resources, and it means it's very expensive. So I want to introduce some statistical downscaling in this presentation. Why the downscaling and bias correction is necessary? As you can see in this figure, there's the red box is one red grid from GCM, and this is a Korean peninsula. And we are interested in very small reservoir in Korea, for example, and then in the case we need to do some spatial downscaling. Also, the right side graph shows that the black line is based on observation, and the color lines are based on GCM. But as you can see in this circle, there is a big gaps between observation and GCM. So we need to do some bias correction from the GCM output. And the important thing is I just said there's a lot of uncertainty in the climate information. So this is a question from my colleague in Korea when I joined APCC. Actually, he said, I cannot believe in any some results from the climate change, because even though within the same watershed and same the river system, someone says actually the stream flow can be increased in the future, and the other says actually stream flow can be decreased like this. So, but that's this kind of a problem caused by one uncertainty of the GCM, because it depends on the selection of the GCM. So in order to avoid this kind of uncertainty, my recommendation is we have to use multi-model ensemble. MME is a multi-model ensemble. It means we need to consider multiple output from multiple GCMs. So this graph shows that if there is a average increase in the precipitation and stream flow from multiple models, shows that 9.1 increase. There's two cases. One is like this. So the variation is huge, but second case is a very narrow ranges. Maybe we can reliable case one, because most of the GCM tears is increase and it's a consistent result. So that's the reason we need to consider uncertainty of the future projection, and the best way is we need to use multi-model ensemble based approaches. So let's think about what is the user-centered downscaling platform. The APCC developed AIMS. This is a user-centered downscaling platform, and if you just stop by a coffee shop, and if there is only one menu, this kind of the menu, and then it means you don't have any choice to select your favorite coffee. But most of the coffee shop shows this kind of menu. It means you can select your favorite coffee based on your some preference. But it means we can decide our coffee based on your some preference. Climate service like this. This is the provide-centered climate data service. It means there's only one GCM and there is only one downscaling, but there's a lot of applications. But my question is, only one the GCM or downscaling can be perfect for all these kind of different applications? My answer is no. And if the answer is no, which downscaling method and GCMs are appropriate for my application? For example, some irrigation purpose, something like that. So, is there any some user-centered crime service in the world? I think no. So APCC wanna actually suggest some user-centered downscaling approaches platform. It means we start from our objectives. For example, application 3 is some water supply for some agriculture sector, and if that's our objectives, maybe we can select which downscaling method is better, and maybe we can select among multiple GCMs. We can select appropriate GCMs for my objectives. So it means users need to provide their knowledge, local knowledge and process, which is important in my application in my area, and that's is a very important information for this user-centered downscaling approaches. And providers, the climate information provider, they usually provide data, tools, and guidelines, and it can be integrated within this system. So let me introduce APCC integrated modeling solution we call AIMS. You can download from this website, and this is the website, and this is the user interface. As I mentioned, we need to do some downscaling of the climate change scenario, and sometimes we need to downscale some seasonal forecast information. So in the future, right now we consider climate change scenario within AIMS, but soon we want to include the seasonal forecast downscaling within this platform. The concept of that AIMS is like this. The left side is climate information, climate data, and downscaling tools, which is included in AIMS. And after that, we need to do some additional analysis, something like how the drought condition will be changed in the future, how the evapotranspiration can be changed in the future, and something like that. Sometimes in application sector, for example, the agriculture and water sector, they are using their own modeling system. For example, in water sector, we are using SWOT for the some water resource, some simulation. Some agriculture sector, they are using some AppSim DSET for growing simulation of the crop. So that's the bottom. That bottom is some linkage between the climate scientists and application scientists, but that's not all. We need to consider provide some information to the decision maker. So we need to do some vulnerability assessment and impact assessment in order to provide some additional information to the policymaker and decision maker. So this is a component of AIMS. As I mentioned, we need to consider the GCMs, multiple models, and after that, we develop some downscaling modules within AIMS, and this is the core engine of that AIMS. After that, actually, we can provide the downscale information to the multiple users, lots of users. So this year we are adding more modules, such as different kind of downscaling module, and also we are considering the interface for SWOT within this AIMS platform. And as I show you, this R package is an independent module. It means you can actually download this module from the R repository, and then you can use this module independently. So this is an example of the RSQM package. You can download from this website, and you can do some downscaling without any AIMS, just using this the R package also. So let's show you some the case study, how we can consider this kind of different the different scale of the crime information. Maybe in the bottom, maybe we can consider remote sensing. It can be used as an observation. And as I mentioned, there's a S2S which covers 1 week to 1 month forecasting, and also there's a seasonal forecasting information which covers 1 month to 1 year. Actually, in APCC, we provide 6 months forecasting information to the users. And finally, there's some climate change scenario data, but we have to do some downscaling for each different climate information. The downscaling approach is a bit different depending on the type of the time scale of the climate information. So we developed this downscaling method, statistical downscaling method for different time scale of the data. And after that, using that downscale data, we can do some actually drought analysis. How the drought condition in the long future, how that the condition can be changed in the future, how that drought will be in 6 months later, something like that. So this one is a 6 months drought forecasting, and this one is the long-term, the climate change projection for long-term future. And then maybe we can consider some SWAT modeling, the watershed modeling, for actually providing stream flow forecasting and long-term stream flow, the projection in specific watersheds. But that's some actually science level some analysis result. But we want to provide this based on this kind of multiple different kind of information. We want to try to provide some information to the decision maker. For example, risk assessment and management framework based on this framework. So we are working on this kind of the risk management framework, but most of the presentation in this slide, it covers some scientific, actually research level approach we applied in Korea, in Thailand. So I will just focus on this part. So as I mentioned, you can download the climate change scenario, and sometime later you can download the seasonal forecast information using the AIMS. After that, you can do this kind of analysis. We are interested in some drought forecasting in my country, and it means we need to do some seasonal forecasting of the precipitation, how the precipitation will be changed in 6 months later, and based on that information, we can apply this kind of daily EDI, and then we can produce this kind of spatial distribution of the drought in from 1 month to 6 months lead time. And the other approach is maybe we can apply monthly EDI. It means we can provide some the drought forecasting over Korean Peninsula average, so area average forecasting. So we tried this kind of 2 different approaches. So for this kind of drought forecasting, I'm using effective drought index. Maybe you are very familiar with SPI, SPEI, but I choose the EDI because it has a very, actually, the strong the point compared to the SPI and SPEI. Let me show that. This one is the case 1 and case 2. This is the precipitation pattern during 1 year, for example. If we are considering SPI, these 2 cases show that the same result, but the EDI shows that the lower EDI value for the case 2. It means the case 2 is more actually significant to the more severe condition, because the precipitation is keep decreasing up to present time. So I think that the impact is more severe in case 2. So the EDI is better for capturing this kind of the pattern of the precipitation. Also, the EDI is better to represent some long-term the drought situation. As you know, SPI, the result is depends on the accumulation months. The result can be changed, the SPI 3 months, SPI 6 months, SPI 12 months, but EDI shows that the very actually consistent, the same result without any that kind of selection of the months. So that's the reason I selected the EDI. And this is the example of the drought forecasting on Korea. The bottom left side, this is a case study for Korea, which I actually forecast on Korean Peninsula, which is issued on February 2018. And right side is we are just starting to do research on the Thailand. It's the northeastern Thailand, and we applied that same approaches on Thailand, northeast of the Thailand. Then this is the one example of the drought forecasting. And the right side is the observed, is based on observed the measured data, and this is showed that 1 month, 2 months, up to 6 months lead time, the drought forecasting for each month. So this is an example. And also we can forecast area average of drought condition. And this is some example of the forecasting scale on Thailand, northeast of Thailand. And average of the drought forecasting, as you can see, actually is reliable, showing that the TCC is greater than 0.5. So we want to apply this kind of the technique and the tools and something like that. And this shows that the climate change impact assessment. So within this graph figure, and the EDI minus value of the EDI means is severe drought, and so we can actually calculate the drought duration from this point to start point to the end point, and also we can consider the intensity of the drought, and also finally we can actually calculate how frequently that drought condition is occurred after a very long period of time. So within these approaches, we just calculate drought duration, intensity, and frequency. And this map shows that based on actual observed data, spatial distribution of the drought intensity, duration, and some number of the occurrence. But what we are interested in, how that the characteristic of the drought can be changed in the future depending on the scenario, RCP 4.5 scenario, 8.5 scenario, and depending on the targeting period. It's a near future, mid future, and far future, something like that. So this is the result, and we want to provide this kind of information to the water resource manager and decision makers for being prepared for the negative climate impact, something like that. So, and this shows that drought duration changes on Korean Peninsula, and the last is a number of the drought occurrence on Korean Peninsula, something like that. So this one is based on some hydrological modeling, and this is one example. Climate change impact on stream flow, especially dam inflow into Chungju Dam, and this figure shows that the Chungju Dam watershed, there's one big multipurpose dam in Korea. So we are interested in how that stream inflow to the Chungju Dam can be changed in the future. So using that downscaled the climate information, we can apply that the downscale information to the SWAN model, and then we can produce this kind of the changes of the stream flow in the future, depending on the RCP scenarios like this. So as you can see in this graph, the black line is based on historical period, and red line is a future projection. So as you can see here, in Korea, the inflow to Chungju Dam can be increased during the July and August and September during the wet season, and that's the information we need to consider for water resource management. And the other application in Korea using that downscaled information is for the agriculture resources, agriculture reservoir. This figure shows that some drought situation in Korea, and that shows that agriculture reservoir in Korea during the drought season. So it is very vulnerable to climate change because compared to that multi-purpose dam, such as the Chungju Dam, this kind of agriculture reservoir, the size of this reservoir is very small. It means it's very sensitive to the climate changes and drought the situation. Left side, this point shows that the location of the agriculture reservoir in Korea. You know, in Korea there is more than 17 to 18 thousand agricultural reservoir exist in Korea, and KRC, Korea Rural Community Corporation, they are managing more than 3,300 reservoir in Korea. So this figure shows that location of the reservoir, which is managed by KRC. So we have to consider how that upstream inflow can be changed in the future, and also how that demands from the paddy field can be changed in the future. And considering that the inflow and demands, maybe we can calculate the reservoir storage using the water balance approaches. So what I did, actually, I downscaled the climate change scenario for the station on Korean Peninsula, and then applied that information to this individual the reservoir in Korea. And this is a final some result which I actually provide to the decision maker. So based on that, the multi-model ensemble MME based approaches, this shows that the inflow, demand, and storage changes on Korean Peninsula based on more than 3,300 agricultural reservoir by KRC. So as you can see here, inflow can be actually increased northwest part, but demands can be increased southeast part on South Korean Peninsula. And so the right side shows them drought condition based on the storage level. Actually, it can be problem this east side and the southern part of the South Korea can be vulnerable to these climate changes. And finally, actually, we can use the seasonal forecast information, how that the storage level of the agricultural reservoir can be changed in the 6 months later. So using that downscaled the seasonal forecast information, we can apply that information to the reservoir model. And this is the example of that one reservoir, which is managed by KRC Kicheon Reservoir. And this is the information here. So I applied that the downscaled the seasonal forecast information to the watershed, and top shows that some precipitation forecasting. The black line is observation, and the blue is the forecast information. And it shows some inflow forecasting and storage forecasting, outflow forecasting. within this 2 year, the application actually, the later one actually, we failed to actually forecast the storage level, but we are just keep working on how we can actually improve the forecasting skill based on the seasonal forecast. And the final output I want to provide to the decision maker is like this. I want to provide based on that the reservoir modeling, and I want to show that which reservoir, which area has which stage of the drought. For blue is okay, but the red one is severe, the very low, the reservoir, the storage, something like that. So maybe we can show that this branch level information or the reservoir individual reservoir level information. So this is the one of the output we are expecting from this kind of approaches. So finally, I just want to APCC's the climate service we are thinking. This is a quiz, but because of limit of time, I just want to show this. And this one is the some puzzle, and it is a boa snake. It swallowed this bottled waters. The reason I want to show this the figure, I just drew this puzzle when I joined the APCC 6 years ago, because there was one international workshop in our center, and I want to deliver this message. As I mentioned, we need to do some. We need to think about the integration between the climate sector, the left side, and between the climate sector and application sector. And downscaling is very important within this the research level. But that information should be delivered to the manager, actual water resource manager. Also, it should be delivered to the policymaker. But we are just working on this research level integration, but we need to keep working on this kind of a vertical integration between the scientist and policymaker. So that's the message I want to deliver to the people. Let me show you about the APEC Climate Center, APCC. Actually, it was initiated during the year 2005 after this APEC meeting in Busan in Korea during the time. So the objective of APCC here, we collect the seasonal forecasting information from different model provider, and we generate APCC MME, multimodal ensemble. It means we improve the forecasting skill based on this MME. We provide this information to the users in the world. But this is some global scale data, so that's the reason we need to do some downscaling for application sector. This is the cycle of the developing user-centered crime service in APCC. We start from research and we develop some service such as AIMS and something like that, and then we do lots of education for the capacity building. So this is an example of the data we provide to the users. If you are interested in the climate change scenario for your country, maybe you can actually stop by this site, and then you can download 29 GCM and 6 water variable, precipitation and temperature, etc. Maybe you can download the information from this service, and then based on that information, you can do some downscaling by yourself using the AIMS for your region, for your country. And this is the data service we are providing. And also, we are trying to provide some user guideline, because sometimes the users in application sector use that the climate information in is a wrong way, in not correct the way. So we want to provide the guideline, which one is the appropriate way we need to consider the climate information in our sector. So this is one of the example of the guideline we provide. And finally, we are interested in the education as a capacity building of the people. APCC, actually, we are not interested in the project, individual project. Actually, we want to provide some platform to the users, and we really want the local expert can do something by themselves through some education of the downscaling, education of something like that. So this shows that the research level education, we have some long-term education. It's a Young Scientist Support Program, YSSP. It covers 3 months the research. We invite the scientists from the developing country. They are visit the APCC, and we work together based on their own problem in their country. And this is a very long-term education program. Also, we provide some downscaling training program every year. It's a 1-week program. And this year, this downscaling training program will occur during the October this year. So we will actually advertise that training soon. And the other some education is for the management level. Last year we opened some project development workshop against climate change, and finally we also provide some policy level education. It's a program. It's the APEC Climate Symposium during the APEC Climate meeting, APEC meeting. So this is an example of that. Some pictures. Actually here's Dr. Actually, he was the lecturer last year. So this is one of the education we are providing. So this is a final slide. So crime adaptation became important under SDGs recently, and in order to do some crime adaptation, maybe the seamless climate information can be used for adaptation measure against climate change, and user-centered downscaling is important, and APCC is provide that kind of some services, and AIMS is the platform you can use for some climate adaptation things. And capacity building, we provide some capacity building for different level of the users, and it is very important for integrating some climate services in this research level and some policy level is very important things. So that's my message about the climate adaptation, considering some seamless climate information. Thank you very much.
Thank you, Mr. Cho, and it was a very useful and a very important area that you addressed in your webinar today. Now we have 2 panelists with us, Professor Watanabe, Chair of Working Group Climate, and Dr. Hyung Yoon, our invited panelist from Canada. So now we would request the panelists to give their views. At the beginning, I can take opportunity to invite Professor Watanabe for his views on this climate change topic.
Dr. Watanabe?
Yes, yes, I'm here. Can you hear my voice?
Yeah, I can hear you. Yeah.
Okay. Then thank you very much, Dr. Choi, for your very excellent, well-organized presentations. Also, you gave a good talk in our working group workshop held in the Mexico City in the last year. And then we proposed your talk as a webinar of ICID. Now I'm very happy we realize your talk as a webinar. Thank you very much.
Yep, thank you.
I do not suppose I am the panelist for your talk, but I have some question and comment. Okay, first of all, I would like to make clear the meaning of seamless. Seamless, you used in your presentation title. Seamless climate service or the seamless climate informations. First of all, I would like you to make clear the meaning of the seamless. Seamless between what? Seamless over what? then first I would like to know that point. So I would appreciate it if you answer now quickly.
Yeah, actually, the reason I'm using the sameness, but right now the people actually they are using the different. Actually, the sameness means that there's a different kind of the crime information is available, but the people actually they are using that information is just it's a separately. For example, if somebody is interested in the crime change long-term projection, they are using the crime change and that's all. But the real actual some climate change adaptation, it should be based on that long-term projection. Also, we need to consider some the forecast based on the data, something like that. So we consider that climate variability, climate change within that decision-making procedure altogether, integration of that the information altogether within one decision-making procedure. That's the reason I'm just using the sameness means it's connected together for just one decision-making. That's my actually my thought. Yeah.
Yeah. Also, I want to add some points in terms of like a definition of a CNF. You asked it. You raised the issues. The sameness include like the temporary or spatially sameness definition, but actually, as you know, the global or climate model has very coarser resolution to apply regional applications such as the hydrological and agricultural management. So this temporary, spatially sameness means like the APEC Climate Center try to provide spatially sameness climate information by the downscaling. Also, with temporally sameness climate information can be provided by APEC Climate Center by providing like a sub-seasonal, seasonal climate change information.
Yeah.
Okay, Dr. Watnabe, do you have anything?
Sorry.
If you have anything.
Any other question or any other
Suggestion?
No, I catch a point there. Dr. Cho, why he used the word of seamless, but no, also I understand APCC is covering the various the white in terms of the space and time, especially you have to cover the four things. But when my point is, I would like to add some kind of somehow different point. When we predict the future, okay, maybe we put some kind of the theme. For example, when we predict that the near future or the maybe 1 month or the 1 year later, we don't think. But when we consider that the future, like end of this year, we have to give a scenario on the changes of the land use or the demography or the also agriculture productions. Okay, then the exact procedure of the predictions quite different for the short-term prediction and long-term predictions. There must be some kind of the theme, I think. Can you catch my point? And when you predict the future drought, so you put some scenarios on the changes of the vegetation, the land use, even the demographies. Drought is affected by the demography. The drought is a kind of the impact, not only the hazard. It will depend on the adaptation and also the exposure. Then I would like to make clear that condition for your future prediction?
Yeah, actually, that's what we are considering. Actually, I shows the diagram. Actually, it shows that some multi-range climate information, how that the information can be used for some drought forecasting, drought projection, and some hydrology modeling. And actually, we just considering the difference between the forecasting-based approaches and climate change-based approaches. You mentioned the drought vulnerability actually can be changed, depends on the climate exposure hazard, and also we have to consider the local sensitivity of the impact. For example, some area has a huge the agriculture area, but the other area has some desert. Maybe that has a very different impact, right?
What happened?
It's okay?
Okay.
Can you hear
It's
me?
okay now. Please continue.
Yeah. And also we have to consider some capacity of adaptive capacity of that region. So it's a very common approach for the climate change vulnerability and things. But if you think about the seasonal forecast approach, for example, we are just interested in 6 months later. But in the case, the demography and most of the things is fixed. It's not changed during the 6 months period time. So in the case, the forecasting information, the climate forecast information is more important in the content. So so that's within the seamless approaches, we need to consider that different the characteristics. So how we can actually emerge that different some vulnerability assessment and risk assessment and within one decision-making procedure. Maybe the climate change projection vulnerability assessment can be useful for changing the criteria of the infrastructure because it takes a very long time. So we can change the system for a long time. But if we have 6 months, maybe we cannot do that kind of changes. We need to focus on management, water resource management, education management, crop management. We can handle that management. That's what we can do. So we have to link that climate information to that kind of management things for the short term, but long term. But we need to consider within the systematic system approaches, something like that. So that's what we are considering in APCC.
Thank you very much. You are developing, we have the same thing to be solved. It's not that point I stated is not so easy to be solved, but we have to develop that kind of approach. Thank you very much. And I have 2 more points. Can I say that later?
Yeah, let us try if somebody else is from the audience. If somebody else is having the point, I am seeing one unanswered question from Mr. Malada Mohammed. If you are hearing and then we are giving you the mic, you can speak your question. Hello.
Hello?
Hello, Mr. Mehta. Can you hear us?
Yeah.
You can raise your question to Dr. Jepel Cho or to the panelist. You go ahead with your question or suggestion.
Please speak.
So, to panelists?
To panelists, to Dr. Jepel Cho, you can raise question to anybody, any of the 3.
Okay. So Dr. Do you have some question or concern? Actually, we can discuss about this kind of topic because you are doing some climate actual change impact assessment in Canada, and you also have very good experience in downscaling. So, do you have some idea we can share about this kind of issues?
Yeah, there's something. So actually, I'm now working at the urban environment in parks. So that we need to develop one of the integrated urban climate change modeling project that include like a surface water modeling and the groundwater, the social impact to develop the climate change adaptation. So I was wondering, you have any plan to expand your expertise to like another components instead of just only surface water component in the framework of AIMS?
Actually, but we start from just very popular the hydrologic model and some agriculture model, but we have some plan actually to expand to the different actually component within the hydrological and any kind of some area. But yeah, we are just keep trying to actually expand the area, something like that.
Yeah, also another point is like to apply the statistical downscaling method. The prerequisition is that we need to have like the very reliable and robust observation. But yeah, unfortunately, for the developing country, they don't have any like the very reliable observation. So in that case, how can you resolve that problem?
I think you point out very important issues because I'm involved in the project in Iran, and also I'm involved in ADB actual project. Recently, they are also involved in Philippines one project, but the most of the problem in that project actually it was very difficult to get the observed data because seasonal statistical downscaling, it requires some very good quality of observation, but most of the developed country, it was very, very difficult to collect the data. But that's the reason I'm using different kind of climate information, maybe such as some reanalysis data and remote sensing data. I did not show in this presentation, but I just tried to evaluate different kind of reanalysis data and including remote sensing data. And the experience that just tells them MERA2 was the one of the good the information we can use for engage the area. And next time maybe I can share that the research through some paper, but I think we can just focus on some grid-based observation such as remote sensing and reanalysis data. That's what I'm thinking about that issues.
Yeah, thank you. Yes, actually, for the North America, we have a number of the grid climate data sets. So we have some dilemma which climate information is the most reliable. So I'm now working on that evaluation with the multiple historical grid climate data set for North America.
Yeah.
Yeah. Thank you very much.
Dr. Jepilcho, there was one question from Mr. Mehda Mohammed, which we have forwarded to you. You can see in the questions part, otherwise we can read it and then you can reply because we have given him the chance to speak, but somehow he's not able to raise his question personally. We can read it.
The question says the average prediction of MENA is up to 2-degree increase in temperature next 15 to 20 years and over 4-degree end of century. The increase is higher for faster emission scenarios.
So he's saying that he is saying that for MENA region, there is a prediction is 2 degrees centigrade increase up to 2050, and then 4 degree up to end of the century, and then it will be faster in the more emission scenario. So what is your view on that? He is asking that.
View? What was the point of the question?
No, he just commented that, and then he's saying that for a faster emission scenario, this rise in the temperature will be much faster as compared to the other scenario. So he has just commented like that. That's all.
Yeah. Actually, recently there's a different kind of the RCP scenario, but recent observation shows that we are just following the worst scenario from different RCP scenario, but even though we are just following some worst scenario, but we have to just focus on the crime variability also, which means it occurred during the recent time. So the increase of the temperatures and some precision amount is a long future, maybe it's important, but the reason I want to present in this slide, the message I want to deliver, maybe in addition to that information also, we need to consider some variability, climate variability, which is we are experiencing in our real world. So that's what I want to tell you.
Okay.
We have flashed one more question to you. If you can see that questions link, you can see the detailed question.
Where's the question link? Where's the questions?
Can you see the chat or?
Yeah. Chat.
Yeah. There is a question also for you.
Dr. Joe, this question is also from again from Mr. Maida Muhammad. He is saying that the response to these changes requires planning, and therefore, for better water resources management, it is important the knowledge about the expected future conditions under climate change scenario. So, can you understand that question?
No, actually, what's the point? So,
Yeah, he's saying that if we have to respond, then we should know the future conditions under climate change scenario. So then only we can do the planning for water resources management, better planning. So your views on that?
Dr. Could you actually answer the question?
Actually, the climate information is dominating some conference and infrastructure in the water. So that's why we need to incorporate climate information into decision making. So also there are so high large uncertainty in the climate information. That's why we need to incorporating the multiple ensemble approach into the decision making. So that's my point of view in the question.
Okay.
Okay. If we don't have any other questions, then we'll close it. Thank you, Dr. Cho, for a very good and informative presentation on seamless climate change downscaling. We also thank our panelists, Dr. Hume and Dr. Watnabe. We also thank our Secretary General, Mr. Pandya, and all the attendees who have participated in this webinar. With the live recording of this webinar. Yeah.
Hello. would you mind if I introduce our workshop in the Saskatoon of the working group of climate?
Yeah, please.
Okay.
Okay, now, okay. Thank you. Now I'm serving as the chair of the Working of Climate, ICID. In the IECD Congress held in the Saskatoon, Canada in August, our working group will hold small workshop in the second part of our working group meeting. Still, we are looking for a speaker in that our workshop. If you have interest in talking something in our workshop, please contact with the central office or the I myself, Watanabe. Please, thank you. Thank you very much.
I'm interested in that workshop, but I'm also interested in the training. The AIMS, I introduced AIMS is some downscaling platform, and we are interested in actually some training workshop. The user can learn how to use the AIMS and create their downscale data for their own country, on their station, and that's also I'm interested in through that the ICID conference, something like that. So if you think actually there's a opportunity for that kind of a training workshop, and maybe we can do something.
Thank you very much. But thank you, Dr. Choi, and also your last part of your presentation regarding the vertical integration. It's very, very important for ICID. Okay.
Yeah.
For the implementing our activity of the working group for the goal B of our roadmap to the ICID vision. We have to develop we have to help developing of the integrated management under the changing climate or for the climate change mitigations. Then that your point is very important. Your talk in our workshop is most welcome. Thank you very much.
Yeah.
And also, Dr. Amy, will you be in Saskatoon?
I'm in Calgary, just on the neighbor with Saskatchewan.
Okay, then if possible, could you please join our workshop? There are other, could you please introduce that case of Canada? Climate.
Hopefully I do. Hopefully I do if possible.
Okay, I will email to you. Thank you very much. Taking this opportunity, I would like to introduce our activity. Thank you very much.
Thank you.
Thank you, Dr. Watanabe.
Thank you.
Dr. Cho, for your suggestion for training of young professionals or other working professionals on AIMS, that will have noted it. We'll contact you separately for that, whether we can arrange some training program in Saskatoon, or we are planning one YP training program in 2019, most probably in Seoul, Korea. So at that time, we can organize this YP training on AIMS, because their YPs from different countries will be there. So we'll look into it at that time, and we'll contact you separately for that purpose.
Yep, thank you.
So how we can utilize your services for training YPs in future. That will do, definitely. Thank you for that. And from ICID, we thank everybody for this very good webinar, and we'll keep in touch and we'll organize a similar webinar in future. A live recording of the webinar will be available on our website under ICID webinar section. So anybody who has missed, they can look into it, and then they can see the presentation and all the discussion. So thank you very much once again, and we'll close the webinar. Thank you very much.
Thank you very much. Thank you.